2026 A-Level Combined Mathematics Paper 1 Part B question number 12 Part A. Part B of this same question will be discussed in a future video, link in the top right. Part A of this question has to do with permutations and combinations. The question says, numbers are to be formed using sum or all of the given 5 digits 3, 5, 6, 7 and 8 without repetition. So basically, if you use one of the digits, you can use the same digit again in the same number. Now given that, they ask us to find the number of different ways in which a number greater than 10,000 can be formed, and then they finally ask us find the number of different ways in which a number greater than 6,000 can be formed. Now to start off with this question, if we consider Roman number 1, the first thing that we should immediately realize is that if you have a number greater than 10,000, this number must be at least 5 digits long. Because if you consider a number that's only 4 digits long, the maximum number you get is 9,999, which is going to be less than 10,000. So therefore, the numbers we consider for this answer must be at least 5 digits long. Now considering what's given in the question, we are given only 5 digits, 3, 5, 6, 7 and 8, and we are told to use them without repetition. So considering that, if we take a look at like a 6-digit number, we can see by the pigeonhole principle, if we use the 5 digits like let's say 3, 5, 6, 7 and 8, we are going to have to use one of these 5 digits again for the 6th digit. Therefore, our numbers cannot possibly be 6-digit numbers or larger. And therefore, the only numbers that we can create that are greater than 10,000 are all the numbers that have 5 digits at the least. Now considering the digits we are given, we can see out of the 5 digits, we cannot possibly create 10,000. And therefore, any number we create must be greater than 10,000. So no matter what order we put these 5 digits in, our number is definitely going to be greater than 10,000. So therefore, what the question is really asking is how many 5-digit numbers can we make using these 5 digits. Now to solve that, we need to realize that if you put one of the 5 digits into the first number, let's say we put 6 into the first number, then for the remaining numbers, we have only 4 more choices, that being the remaining 4 digits other than 6. And from that we can see the next number has 4 choices, the number after that's going to have 3 choices, and then 2 and 1. So therefore, the number of combinations here is simply the factorial of however many digits we have to use. Now according to that, what we can do is write down any number greater than 10,000 has at least 5 digits. And then we can say, since we are given exactly 5 digits, the answer is the number of different permutations of those 5 digits. 5 digits. Now according to that, if we write our answer, the number of different permutations of these 5 digits is going to be equal to 5 factorial. And therefore, number of ways to make a number greater than 10,000 is equal to 5 factorial. Now 5 factorial is equal to 5 times 4 times 3 times 2 times 1 based on the definition of factorials. And simplifying this down, we can see 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120. And therefore 5 factorial is equal to 120. So there are 120 ways to create numbers greater than 10,000 using these 5 digits. Now moving from that, the second part of the question says, find the number of different ways in which we can create a number that's greater than 6,000. Now for this one, we need to realize that if you create a number greater than 6,000, the number you create is either in between 6,000 and 10,000 like so, or it is a number greater than 10,000. So it fits into one of these two cases. And the second case we have already found. For the second case, we know the number of different numbers that are greater than 10,000 that we can create is equal to 120. Now due to this, we don't actually have to find the number of different ways that we can create things like this. We can directly substitute 120. Instead, for the second part of the question, all we need to do is to find the number of different numbers we can create that are in between 6,000 and 10,000. Now for this, I'm going to make the statement that if a number is, let's say number n is greater than 6,000, and I'm going to say case 1, we can say like it is either, and we can say case 1, it is in between 6,000 and 10,000. We can put the equal sign here, even though it's not possible with the digits, like, with the digits 3, 5, 6, 7, and 8, it's not possible to be equal to 10,000, but we put the equal sign anyway. And then we can write case 2, where the number is something bigger than 10,000. So we can say 10,000 less than n. Now, if we consider the possible numbers that will satisfy case number 1, we can see, since our number n must be greater than 6,000, the number n must have at least 4 digits. Furthermore, since our number n has to be less than or equal to 10,000, and it being equal is actually impossible here, our number n must have less than 5 digits. Now combining those two conditions, we can see the number n must have exactly 4 digits. Now furthermore, we can also see, since our number is greater than 6,000 and it cannot be equal to 6,000 based on the digits that were given, our number must start with either 6, 7, 8 or 9. And it cannot start with 9, since 9 is not one of the digits that were given in our set of 5 digits. So according to that, the number n must start with either 6, 7 or 8. So it must be either 6 and 3 more digits, or 7 and 3 more digits, or 8 and 3 more digits. Now according to that, if we go down and consider case 1, we can say from case 1, the number n must have exactly 4 digits, and the first digit must be 6, 7 or 8. Now for the total number of values n that will satisfy this, what we have to do is to consider the total number of digits that we need and consider how many different choices we have for each digit. Now considering the first digit, the total number of choices we have is 3. We have 3 choices of either 6, 7 or 8. So we have 3 choices for the first number. Now once we put one of those numbers, for the remaining digits, we actually have all of the choices from all the rest of the numbers. We have, let's say we take 6 as the first digit, then we have all the choices of 3, 5, 7 and 8 for the remaining digits. So therefore, for the remaining digits, we can put one of the remaining 4 for the first digit, we can put one of the remaining 3 after that for the second digit, and we can put finally one of the remaining 2 for the last digit. So according to that, if we write down, we can say choices for the first digit, choices for the first digit equals 3, and for the remaining digits, we can put any of the 4 digits into the 3 remaining places. And therefore, for the first digit we have 4 choices, for the next one we have 3 choices, and for the last one we have 2 choices. And therefore, the choices for the next 3 digits is going to be equal to 4 choose 3 times 3 factorial. We can literally put anything we want into the remaining spaces. Now due to this, if we simplify, on the top here we can see we have 3, and for this one 4 choose 3, we have to substitute in 4 factorial divided by 3 factorial times 4 minus 3 factorial, which is 1 factorial, times 3 factorial, and if we cancel these two, we can see we are left with 4 factorial, which is 4 times 3 times 2 times 1, which is equal to 24. And therefore, the number of choices for the last 3 digits is 24, and the number of choices for the first digit is 3, and therefore, total choices, or we can say total ways, is equal to 3 times 24, which is equal to 72. And therefore, the total number of combinations for case 1 is equal to 72. Now, for case 2, if we take it, we can just directly write case 2 has total ways equals 120 from above result. Now, combining these two, we can say, therefore, total ways to make a number greater than 6,000 equal to the total number of ways that we can make a number greater than 10,000, which is 120, plus the total number of ways that we can make a number in between 6,000 and 10,000, which is going to be equal to 72. And adding the two together, we get the final answer of 192. And with that, we are done with this question. Now finally, let's go up and discuss the marks awarded for this question. So at the start of the question, when you make the argument that any number greater than 10,000 has at least 5 digits, and since we are given exactly 5 digits to use without repetition, all of the numbers we create will be exactly 5 digits long. And from that, when you say the total number of numbers we can make is equal to the number of different permutations of those 5 digits, you get 5 marks. Now from that, when you say that the number of numbers we can make is equal to 5 factorial, you get 5 marks. And when you simplify that down and get the final answer of 120, you get another 5 marks. Now moving on to the second part of the question, when you consider numbers n which are greater than 6,000 and realize they either belong to case number 1, which is numbers in between 6,000 and 10,000, or case number 2, which is the numbers greater than 10,000, for writing down these two cases, you get 10 total marks. Now from that, when you consider the first case and realize all of the numbers n you create must have exactly 4 digits, and the first digit must be either 6, 7 or 8, and from that, when you say the number of choices for the first digit is equal to 3, you get 5 marks. And after that, when you consider the last 3 digits and say the number of choices for the last 3 digits is equal to 4 choose 3 times 3 factorial, you get 5 marks for that. And simplifying that down, when you get the answer of 24, you get another 5 marks. And finally, when you multiply this number and this number together to get the final answer of the total number of ways as being equal to 72, you get a final 5 marks. Now after that, from the last part of the question, when you combine these two numbers together for case 1 and case 2, adding them together get 120 plus 72, which is 192 as your final answer, you get a final 5 marks. Now it should be noted that since the marking scheme is not available, what I've done here is just a rough approximation of the marks you'll get. You could get more or less marks or get marks in different locations depending on the final marking scheme. However, this rough approximation is good enough to get you a rough mark for what you get for the actual paper. Now finally, let's conclude this lesson. So that's the end of this video. Thank you for watching and goodbye. So that's going to be the end of this video. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.